Hey everyone, today we are gonna solve this Schrödinger wave equation where your psi of r theta comma phi is 2 by 3 times z by 3 a naught whole power 3 by 2 times sigma minus 1 into 12 minus 8 sigma plus sigma square into sigma into e power minus sigma by 2 into cos theta. Yeah. So, yeah. So, while starting this, I just want to add that I will first be covering your quantum numbers and then I shall be going forward with your notes, and then we will be going to our question because these concepts are required a bit for solving this question. Yeah, first quantum numbers. Here there are four types of quantum numbers. First one is principal quantum number, second one is azimuthal, third one is magnetic, and the fourth one is spin quantum number. So first I want to speak about principal quantum number. Okay. It was proposed by Neil Bohr. It's represented by n. It actually says the energy value of the given orbit. Yeah, your 1s, 2s, they belong to the first orbit. 2s belongs to the second orbit. The velocity of electron, time period, frequency, radius, all such factors depend on this principal quantum number. Okay, this is all about principal quantum number. Next one is about azimuthal quantum number. It's represented by L. It was proposed by Sommerfeld. Yeah. So it actually says about the orientation. The shape of the given orbital. Okay. So L equals to 0 gives your s orbital. L equals to 1 is p orbital. L equals to 2 is your d orbital. And L equals to 3 is your f orbital. While talking about the shapes, s orbital is spherical in shape. P orbital is dumbbell in shape. I shall be showing you the pics of s orbital and p orbital. While coming to d orbital, it's double dumbbell. While coming to f orbital, it's complex shape. Yeah, we can't draw it on the paper. Generally, we discuss until the 12th class. Mostly, we discuss about these three, and this will be also discussed. But the furthermore orbitals like G, H won't be discussed. Yeah, might be due to like just like they might ask, but not that important. Yeah. So. Next one is your magnetic quantum number. which is denoted by m, which is the orientation of the given orbital, subshell to be precise. Yeah, its values range from minus L to plus L, including 0. And for L, the values range from 0 to n minus 1. Yeah, okay. And you can also denote the angular momentum using this azimuthal quantum number, where L is given by root L into L plus 1 times h bar, where your h bar is again h by 2 pi. Okay. This is what. And your last quantum number is spin quantum number. Okay. It tells about the spin of the electron. Its values are s equals to either plus half or s equals to minus half. In general, according to Hund's rule, no two electrons with the same spin can be accommodated in the same subshell. Like here, this orientation is wrong. Okay. Whereas this orientation is right according to Hund's rule. So here, in general, we consider this as your positive upward spin, or s will be equals to plus half, and your negative one will be this one. It's represented like this. Okay. This is how your spin is represented in general. Okay. Now, this is what I wanted to tell about the quantum numbers. Now coming back to nodes. A node can be found if the probability of finding the electron is 0. Okay. The probability of finding electron is 0. Okay. They are having two types of nodes. One is the radial node, another one is the angular node. Radial node is given by the formula n minus L minus 1, and angular node is given by the formula L, where n is your principal quantum number and L is your azimuthal quantum number. Okay. Now, to discuss about the principal the angular node, yeah, here you are seeing some dotted lines, whereas in this you aren't see. I didn't draw any dotted lines. While finding the number of radial nodes, it has 0 radial nodes, while this has 1 radial node. Those dotted lines actually represent the number of radial nodes. Okay. So in the atom, we consider nucleus as our central point or the center one, and until the circumference, that's how we calculate the radius. So along the radius, if you find any point, which is actually, the probability of finding it is 0, then that will be your uh, radial node. Okay, that's how you find your radial node. And in this 2s orbital, this point is where you can't find any electron. While coming to ang- angular nodes, this here, if you consider this and this as your axis, if this is your x-axis and if this is your y-axis, if you consider a plane in this x-axis, okay, you can see that you can't find any particular node. Okay, you can't find any you can't find any, what do we say, yeah, electron. So the probability of finding electron in this plane along the x-axis is 0. So that's why you are having this one angular node. Okay, and in this portion, it's actually only this portion is where you can't find the electron, and this is of 3p, and here you can't use any plane. Within the plane there will be like, it's like spreaded. Actually this electron cloud is actually spreaded. So not the electron cloud, I think my vocabulary might be wrong, but yeah, this one where I am shading this portion, you can't find the electron. So that's your radial node. Okay, and this is your angular node. Whereas in 3D, you know that there is no radial node, or you are having only angular nodes. So this here I drew two planes. These two planes are your angular nodes, and as we discussed below, the angular nodes are equal to number of, the azimuthal quantum number. And I forgot to add the point that your azimuthal quantum number is also said as angular momentum quantum number as well as subsidiary quantum number. Okay, yeah. So this is what I wanted to discuss about nodes. Yeah. While coming to the question, let me first copy this question. Yeah. So here you are giving the wave function psi of r theta comma phi. Okay. So basically, this wave function has roots. Okay, these roots are none other than your quantum numbers n, l, m. Okay, so generally it's represented as psi n, l, m. Okay, that's how you represent this. So these are your quantum numbers. Okay, the roots are your quantum numbers. While coming to solving it, psi of r theta comma phi can be actually written as r times r times phi times theta comma phi. Okay, this part is your angular node, angular part, and this is your radial part. Yeah, so here you are having this as your radial part and this as your angular part. Generally, yeah, to find the roots, to find the nodes, either your psi square should be 0 or your psi will be 0. Okay, so here while solving this radial part completely depends on r, and the angular part completely depends on theta and phi. Okay, while solving your radial part, the number of roots will be your number of radial parts. Okay, and if you solve the above equation, it's sigma times sigma minus 1 times 12 minus 8 sigma plus sigma square. This part should be equals to 0. And I forgot to tell you another point, that here in this question it's not dependent on the value of n. Generally, this exponential term e power minus sigma by 2 in this question is generally given by e power something. What's that something? Let me tell you. E power minus zr by a naught. Let's assume. So in general, it's this term is zr by na naught. Okay, and in general you compare this value. So here, if you assume this is your exponential part, then your value of n will be equals to 1. Okay, that's how you actually determine. But in this question they haven't been giving anything about the value of n, so which is actually not necessary to teach, but I am teaching. Okay, and your psi is actually a complex number. And your mod psi square is always a real number, because you are taking the modulus of a plus ib, then it's is a square plus b square whole root, which is again a positive complex number, not a real number. Yeah, while coming to solving it, here your roots are sigma equals to 0, sigma equals to 1, and (12 minus 6 sigma minus 2 sigma plus sigma square equals to 0), where 6 minus sigma into 2 minus sigma will be 0. Okay, so sigma will be equals to 6 and sigma will be equals to 2. Okay, so earlier I told you that number of radial nodes will be equal to the number of roots, and while solving this you got 4 roots: sigma equals to 6, sigma equals to 2, sigma equals to 1, and sigma equals to 0, right? Yeah, but if this will be true, will be your radial nodes if and only if sigma is not equals to 0, or r is not equals to 0, to be precise. Okay, why? Because if your sigma is 0, the given equation is saying that sigma is 0, sigma is 2 times z r by a naught, right? If sigma is 0, that means your r value will be 0. If your r value is 0, that implies that this will be your nucleus, and it's quite obvious that your nucleus cannot be your node. Okay, yeah, so that's why sigma equals to 0 is overruled. While coming to other parts, it's still valid, because there might be a chance that you can find it anywhere. When your sigma value is 1, sigma value is 6, sigma value is 2. So your number of radial nodes will be 3 instead of 4, because sigma equals to 0 is overruled. Yeah. So here in this 43rd question, you are having two options, both A and C, as the number of radial nodes will be 3. While solving it further, I will be saying that while solving it further, I would be saying is mm, yeah, sigma equals to 1, sigma equals to 6, sigma equals to 2. While coming to the angular part, generally for your pz, it's k times cos theta. For your px, it is k times sin theta sin phi. And for your py, it's k times cos theta sin phi. These proofs are actually there in your further classes. If you study more, then you can actually find these proofs in some of the good books like D.A. Mercury, yeah, or Peter Atkins. In those books, you can find the proof for this. Why is it? What is the constant value? Actually, for pz, it is a k value, as much as I remember, it is 3 by 4 pi whole power 1 by 2. Okay, for pz. Yeah, these proofs, when you study further in your classes, I mean in your higher classes, you can find it. So the orbital will be pz. Okay, this will be the answer for your 45th question. And for your 44th question, the number of radial nodes are equals to n minus l minus 1, which is 3, because we found there 3 rods, actually 4 rods, but sigma equals to 0 is overruled because it represents nucleus. So those 3 rods are sigma equals to 1, sigma equals to 6, and sigma equals to 2. And your L value is, as it's a p orbital, the L value is 1. We spoke earlier that we spoke about this earlier, that the L value equals to 2 for D, and for S it's L equals to 1, L equals to 0, and for F L value is 3. So here we got to know that our orbital is P, Pz is the subshell. So n minus 1 is your 3, and you get n equals to 5. Okay, this is how you find your n value. Okay, and you got your n value, you got your p value, l value, and to represent an electron, it's given by this, where x is the number of electrons unpaired, something which, okay, so it's n equals to 5 and l equals to 1, so the orbital will be 5p. The interesting part of this question, the maximum distance of radial node from the nucleus. Radial node is the place, radial node is actually where the when you measure your radius along, when you go radially, the probability of finding electron is 0 in the atom when you go radially, that means along the radius. Okay, that's what radially means. So to find the maximum distance of the radial node from the nucleus, first let us calculate the distances from the radial of the radial nodes. So here you got sigma equals to 1, that means sigma equals, and question says that sigma equals to 2 zr by a naught. So 1 equals to 2 times zr by a naught, where a naught from this Bohr's model is a constant of 0.529 angstroms. Okay, yeah, this is when you study in the Bohr's model, you get to know that this is your a naught value for hydrogen. hydrogen atom, only hydrogen atom, because there you don't depend on the value in the hydrogen atom. The value of Z is 1 and other values are 1, whereas this A naught for He plus atom might change. It depends on actually it depends on the orbital, orbit, because you will be having some relation like A will be equals to A naught times n square by Z. When you go through your Bohr's model, you will find this relation. Okay. uh, so now we are finding the value of r will be A naught by 2Z. Okay, that's how you find your, like, when your sigma is 1. Now if your sigma is 2, then your r value will be A naught by Z. Simply just substitute all your values there. Similarly, you keep the value of 2, then you get. Now again for 6, let us denote this as your R1, this as R2, and sigma equals to 6. You'll get R3 equals to, again you substitute the value of 6 here, then your R3 will be 3 A naught by Z. Yeah, so considering A naught by Z is some constant K prime, so with this you can make the conclusion that R1 is less than R2 is less than R3. Okay, and the maximum distance is R3 because it's far from the nucleus, and that's the distance where you can find your, these all three are the distances where you can find your radial nodes. So the answer for this question will be 3 A naught by Z. Yeah, that's it. Thank you guys.